Hi students, my name is Whitney Neiswanger, and I'm going to be one of the two instructors for your course this semester. I want to make this first short video to just review some stuff on fractions. In case it's been a little while for you, it's kind of nice to have a quick review. This is probably stuff that you've learned before, but you may have forgotten. Okay, I'm just going to go to my whiteboard and share some stuff about how fractions work, multiply, divide, and add and subtract fractions. Right. So let's share our whiteboard here. There we go. So the first thing I want to remind you guys is kind of what fractions look like, right? There's something on the top. I mean, we could have a fraction that looks like, say, 2/3. Right, so this fraction, 2/3, the number on the top is the numerator. Here's our numerator. All right, and that's the number of pieces we have, okay? Let's put that here. That's the number of pieces we have. Okay, that's the number that goes on the top. And then the number on the bottom is called the denominator. Right? And the denominator represents how many pieces there are in a whole. Right, so that's what those two numbers represent. The number on top is how many of the pieces you have. The number on the bottom is how many pieces it would take to make one whole, right? So something to keep in mind is this denominator really kind of gives you an idea of the size of your pieces. Okay. That's kind of what the denominator tells us is how big our pieces are. And actually, as the denominator gets bigger, it takes more pieces to make a whole. So the bigger that denominator is, the smaller your pieces are, right? It's like if you have a pizza. If you have a pizza and you cut it into 4 pieces, your pieces are really big, right? So then your denominator is, let's say you have one of those 4 pieces. Your denominator is a 4, okay? But if you take that pizza and you cut it into 8 pieces, now your pieces are a lot smaller, right? And so having just 1/8 is a lot smaller than having 1/4, okay? So the denominator tells you the size of your pieces, but since it tells you in a way that's how many pieces to make a whole, the bigger your denominator, the smaller each of your pieces are, okay? But that numerator is actually telling you how many pieces you actually have. So that's how many pieces we have on top, and the number on the bottom is how many pieces to make a whole. Okay. So that's just a little refresh on what our fractions mean. Now let's take a look at multiplying fractions. So it's actually easier to multiply and divide fractions than it is to add and subtract. So that's why we usually start with multiplying fractions, okay? When you multiply fractions, you multiply straight across. All right, so we're gonna multiply straight across. For example, if we have 1/2, and we're going to multiply it by, say, 2/3, we literally just multiply straight across. So the two top numbers get multiplied, 1 times 2, and the two denominators get multiplied, the 2 times the 3. Okay, so we multiply straight across to get our new fraction. So 1/2 times 2/3 is going to be 2/6. Okay. But if you remember how to simplify your fractions, we can also simplify that by saying we've got a 2 on the top and a 2 on the bottom. And since everything's in factored form, that could actually simplify to 1/3. Okay. Another way to read multiplication of fractions is when we say 1/2 times 2/3. Sometimes we read the multiplication as an of. So this could be read as 1/2 of 2/3. Okay. So if you wanted to figure out what 1/2 of 2/3 is, you would multiply. Okay. And then you can conceptually understand, well, if you have 2/3, half of that is just going to be 1/3. Okay. So that's multiplication. You multiply straight across. Okay. And it's pretty simple. So that's your multiplication. Don't forget that, because we have to use multiplication to do addition and subtraction sometimes. Okay. Let's take a look at division. Sorry, that word is reciprocal. So we divide by using the fact that division is the opposite of multiplication. Okay, so what happens if, let's say we want to do 1/4 divided by, sorry, let's divide that guy by 2/3. Okay. Division is the opposite of multiplication. So if we do two opposites, we basically get back to where we start, right? Like a double negative kind of thing. So when we do division, we never actually do division of fractions. We just convert it into multiplication by the reciprocal. Okay. So the first number, the 1/4, first fraction is going to stay how it is. But then we are going to take the opposite of division, which is multiplication, and the opposite of 2/3, which is 3/2. And there we've done kind of a double negative thing where we've done two opposites. So we actually get back to the same thing. So 1/4 times 3/2. And I don't know if it helps if I do those guys in red. Okay. So we did the opposite of our division, which is multiplication, and the opposite of our 2/3. And opposites of fractions we call reciprocals, where we just flip that fraction. All right, so we never actually do division, we just do multiplication by the reciprocal. And now since we're looking at multiplication again, we just multiply straight across. So we've got 1 times 3/4 times 2, and that gives us 3/8. Okay. So that's how division works. It's multiplication by the reciprocal. So we just flip those. We keep your first fraction the same, remember that, and then you flip the other two. Right. So that's our division. So let's move on to adding fractions. When you add fractions, you really want to remember what those pieces of the fraction mean, right? The top number is how many pieces you have, right? And so you're going to add up the number of pieces that you have. But the bottom number gives you an idea of the size of your piece. So just like if you have a bunch of random coins in your pocket, you know, say you have 2 pennies and a nickel, you can't just say I have 3 coins, because that doesn't really convey how much money you have. What you do is you say, well, this nickel is really worth 5 pennies, right? So in your mind, you break the nickel up into the same size pieces as the pennies. And you say, well, I actually have, you know, the nickel is 5 pennies, and then I have 2 more pennies. And so then you add the number of pennies you have, and you say I have 7 cents. Okay. So just like when you add up coins that are worth different values, what we have to do is we have to make sure that all of our fractions have been changed into the same size pieces. Okay. So that means that we have to make our denominators all the same, since our denominator tells us what the size of those pieces are. Okay. So let's do an example. Let's do 1/12 plus 3/8. Okay. So here we have different size pieces. The 12th, you know, this first piece is 1/12. So it's a pretty small piece. And we have one of, and this we have 3 of these pieces that take 8 to make a whole. So these pieces are a little bigger than this piece. Okay. So what we need to do is make them the same size. And to do this, we use this trick of multiplying by 1. Oops. But this 1, I don't know if you notice, I put it in quotes, because we're not just using a regular 1, because then we just end up with the same thing. We're using a special version of 1, which is going to be a fraction where the numerator and the denominator are the same. Okay. And in doing that, we will be able to change the way our fractions look without changing their quantity. It's basically taking a nickel and trading it in for 5 pennies. Okay, we change the number of coins we have and the value of each coin, but in the end, we're still staying with the same amount of money, right? A nickel and 5 pennies are the same amount of money. Okay, so that's what we're going to do here. The tricky part is, okay, which version of 1 do we use, right? And sometimes that's not that easy to see, but here's where they come in with that acronym you guys might remember called the LCD. LCD stands for least common denominator. And what that means is, what's the smallest number that is a multiple of both our denominators? So the LCD is the smallest number that's a multiple of 12 and a multiple of 8 here. Okay, that's what our target, our new denominator is going to be. So we want to change both of our fractions by multiplying by some version of 1 in order to get both of our new fractions to have a denominator that is a multiple of 12 and a multiple of 8. Okay. So you can start by finding your target LCD and then working backwards to see which version of 1 you need to multiply by. But actually, you don't even really need to know what your LCD is going to be. We can just break apart our different denominators and figure out what each of these is missing to make them be the same. Okay. Let me move to a new whiteboard and we'll continue this problem. So 1/12 plus 3/8. All right. So what you are going to have to do to make these denominators the same is you're going to have to factor both your denominators. So let's take our 1/12. And let's see what all the factors of 12 are. Okay, so 12 is going to be 2 times 2 times 3. Okay, that's our 12. Let's see. So the 12 became 2 times 2 times 3. Go ahead and confirm 2, 4, and 4 times 3 is 12. So we just rewrote 12 as a product of its factors. And then we can do the same thing for our 3/8. So 8 is actually 2 times 2 times 2. Okay. So now we can see what is different in both of these fractions. Okay. What the difference is, they both have those 2 2's, but this 12 has a factor of 3, which the 8 does not have. And this 8 has a third factor of 2, which the 12 does not have. Okay. So what we're going to do is multiply each of these fractions by a version of 1. That's essentially going to, we need to give the 8 a 3, and we need to give the 12 a 2. Okay. So our 1/12 is going to get multiplied by a version of 1, which means it's going to get multiplied by a 2/2, because that's the factor that the 8 has that our 12 does not have. Okay. And then our 8 is missing a 3, right? Our 8 is missing this factor of 3 that the 12 has that the 8 doesn't have. So we're going to multiply our 3/8 by 3/3. Okay. So all we had to do was factor our denominators and figure out what pieces each one is missing, right? The 12 over here is missing a factor of 2. The 8 over here is missing this factor of 3. And then we give them those factors. But the trick here is we are literally just multiplying by 1. 2/2. 2/2 is just 1. 3/3 is just 1. So we're doing this special thing where we're multiplying by 1 inside of our addition problem, just to make stuff look different without actually changing it, right? We're taking our nickel and exchanging it for 5 pennies. So it's going to look different, but it's going to represent the same quantity. So now instead of 1/12, we've got 2/24, right? 1/12 and 2/24. And instead of 3/8, we've got 9/24. Okay. So this, this guy, 12 times 2 becomes 24, and 8 times 3 becomes 24. That 24 is the LCD. Okay, that's the smallest number that's a multiple of both our denominators. Okay, that's what the LCD means. Now, this 2/24 is the same thing as 1/12. It's just we have more pieces, but they're smaller pieces, but it's the same amount of stuff. This 9/24 is the same as 3/8. We just have more pieces, smaller pieces, but it's the same quantity. Now you see we have the same size pieces. So we just have to add up how many pieces we have. So now we get to say we've got 2 plus 9 all over 24, and 2 plus 9 is 11. So we've got 11 over 24. Okay. That's adding fractions. If you want to go back and just watch that one more time, I really explained it in a long way, but it's pretty simple once you get the hang of it. The difficult part is learning how to factor, and then remembering that you're not following some crazy rule. Don't just change things like magic. The way we're changing things is by multiplying by these versions of 1, right? Nothing gets changed by magic. Things get changed with very strategic tricks that actually aren't that crazy once you realize, oh yeah, you can multiply anything by 1 without changing its value. So 1/12 and 2/24 must represent the same quantity. And if you want to draw out a pizza where somebody cuts your pizza into 12 slices and gives you 1, or cuts your pizza into 24 slices and gives you 2, you'll realize you're getting the same quantity of stuff, okay? So that's adding fractions, and subtracting fractions is the exact same thing. You would just do a subtraction of the number of pieces you have in the end, okay? So that's adding and subtracting fractions. Let's go to one more example of adding and subtracting fractions that can get just a little bit trickier, okay? So sometimes when you have variables, sometimes students get a little confused on their variables and how they factor, but let's just do a little example. So now we've got a subtraction problem. Like I said, subtraction, same thing as addition. We just subtract the number of pieces after we've gotten them to be the same size pieces, okay? So here, before we remember, what we want to do is multiply each of these fractions, by some version of 1. Okay, I'm gonna give myself a little more space here. Okay, we want to multiply each of these fractions by some version of 1. Really, that version of 1 is going to be a fraction where the numerator and the denominator are the same. Our goal is to make both of these denominators look the same. So what we need to figure out is, what does this 25x need? And what does this 10x squared need? Okay, so here's where we use the LCD. So just on a little side note, let's look at our 10x squared. What are all the factors of 10x squared? Well, 10 is 2 times 5, and then x squared is x times x. Okay. And then our 25x is 5 times 5 times x. Right. So then we have to take a look at what is missing that each of these guys need. The 10x squared, this is a 5 times 5, oops. The 10x squared is missing a factor of 5, right? The 25x has a factor of 5 that our 10x doesn't have, okay? So we know that our version of 1 over here is gonna have to have a 5 in it. And if we multiply by 5 on the bottom, we have to multiply by 5 on the top because we're only allowed to multiply by these versions of 1. Now, what does our 10x squared have that our 25x doesn't? Okay, our 10x squared has a factor of 2 that our 25x doesn't, and it has a factor of x, that our 25x doesn't have. So we're gonna have to multiply this guy by a 2x. Okay. And then what we should end up with is we should end up with fractions where both the denominators are the same. Okay, so we're going to do this little multiplication piece here. Remember, we multiply straight across. So we're going to do 3 times 5 is 15. And 10 times x squared times 5 is going to give us 50x squared. Okay. So this 15 over 50x squared is the same thing as 3 over 10x squared, right? This fraction here is the same thing as our original fraction. We just multiplied it by this version of 1, which is 5 over 5. Okay. And then we're going to subtract from that our other fraction, which we also rewrote. Now, our 1 times 2x is just going to be a 2x in the numerator, and our 25x times 2 times x is going to be 50x squared. All right. So that's our LCD. Our LCD is that 50x squared, right? That's the smallest number that's a multiple of 10x squared and a multiple of 25x. Okay. Now that we've done that, we can do the subtraction. And our subtraction, remember, is just going to be the pieces on the top, 15 minus 2x over the same size bottom. So it's all 50x squared, right? And it turns out we can't go any further than this. We've now combined our two fractions into one fraction, but that's actually going to be our answer right there, okay? Right, so don't let variables in the denominator mess you up. Just count them like as if they were some prime number factor, okay? So that is adding and subtracting fractions, even when they have variables in the denominator. Okay, hopefully that review was helpful.